Okay, everybody, this is the pre-recorded screencast that I told you one of the two that I said I would be making. And we're over here in Module 13. And of course, I've gone over what's happening in terms of the flex time and all that business. I have a link here in the announcements at Canvas for Monday, the 29th, and then on Wednesday, the 1st of May. I'll be there just for class and available to help you and also be online. So you'll have plenty of assistance available if you need it. We're going to look first here at the PDC model, and let's take a look for just a minute what we're talking about here. We're, of course, over in chapter. Well, we've looked at PDC. I'm after PDC. I want the scoring model, excuse me. I've got PDC on the brain here, folks. I'm sorry. Let's go back here. And, well, we've looked at PDC. We want to look at the scoring and the AHP. And just to make things a little bit easier, I think I had the scoring first. I think it appears in the chat text first. And then we'll do this. There, we'll stretch these out a little bit. So we've got the scoring key and the AHP, XLS, and the AHP key. Now, we're going to look at this. We're going to look at scoring first. And we're over here in chapter 14, okay? And we'll go over here to the text. Here we're talking about multi-criteria decisions. Now, so far we've worked basically with optimization, where we've looked at a minimum, a maximum, or a target value. And then we've had changing variables, and then we've had the constraints. Here we have, and those constraints are really not decision criteria, they're constraints. And then we look at the variables that we need to change. So now we're looking at multi-criteria decisions and goal planning, and we'll be working with that. And in fact, the AHP, pardon me, the scoring is in 704 to 707. So let's take a look at that for just a moment. I'll go back to the module. Okay. I'll go over there to chapter 14. And the authors give us some of the introductory materials, concepts like goal programming and graphical solutions, dealing with more complex models. We're going to focus on over here on scoring models. And I will leave it to you to go back, if you care to look at those forms of multi-criteria decision-making models that involve goal programming and formulation, and then some of the more complex uses of it. The scoring models are going to be the ones I think probably, I'm fairly certain of, that you will be working with or dealing with. And we're given a simple example, but for many of you quite pertinent, and that is trying to decide which of 3 job offers that this person wants to take. And they have 3 offers here: a financial analyst for an investment firm in Chicago, an accountant for a manufacturing firm in Denver, and an auditor for a CPA firm located in Houston. Okay? And we get some verbiage here from the authors about the student's perception of the job offer that they want, but they've got multiple criteria, and here they are. And so when we want to work through a choice decision, okay, then we start to talk about following a prescribed sequence. The first one is obvious. We develop a list of criteria that we want to be considered, and then we weight those criteria. Here we are again. We're using a weighted model to get, well, we're using weighting to get ourselves a weighted model for our decision. Then we assign ratings, and then we compute the score for each one of these. Now, and I forgot to mention that, well, I have a key here for you that I'll go ahead and I'll make it available on the scoring. I'll go ahead and publish it. Okay. I have some materials here before we get into the text that have a little bit more of a practical application. These are some additional or supplemental materials that I think you ought to take a look at so you can put the scoring or multi-criteria decision making into a fuller context. And one of them deals with the management theorist Herbert Simon, who talked about theories of bounded rationality and satisficing. And what Simon said, isn't that funny? What he argued or proposed is that all of us have a limited understanding of the world around us. And so consequently, our rationality is bounded. If I'm a manager working in an aerospace firm, the truth is, no matter how smart I am, I probably would be a miserable failure running a restaurant because they're two different kinds of organizations. And although some of the things like logistics, load balancing, etc., would apply in making an airplane just as it would apply in running a fast food operation, the industries are completely different because of the context of what's being sold, the context of what is being, the content of what is being sold, and the employees that you're dealing with, and the expectations of a general public versus the expectations of a government of a government agency or something like that. So it says you have bounded rationality. So it said when companies hit those points, okay, they tend to engage in satisficing it. This gives me an occasion to show off my annotational skills more again. So I'm gonna, let's see, I'm gonna do a little drawing here. Okay, here we go. And I'll put that. And you say, are you about to do that known and unknown thing again? Yep, I am. Remember, we talked about this the other day. And we're into that. As we talked about before, When we deal with problems, we have those that are known and, pardon me, states of nature that are known or unknown, and then alternatives to deal with those conditions that are known or unknown. Okay? And so when we talk about a multi-criteria decision making, as we are over here in this chapter, okay, then we've got to understand that the rules that apply in one place may not apply in another. Or when we're dealing with our situation, say like people making an airplane, or folks who are in the pharmaceutical industry, or people who are developing and selling financial products, it doesn't matter. You have bounded rationality. And this is the part of the rationality or your knowledge or understanding. And if you've taken like data administration with me, we've talked about that. Data, information, which is data collected for decision making, knowledge, which is information that's replicable, and then wisdom, which is business knowledge that's applicable in either just about every situation or for a very, very unique situation that calls for great discretion in your decision making. So companies engage in satisficing. They try to move the line over here a little bit in terms of what's known. Same thing here. But they'll generally make a decision that's not necessarily optimal. Large organizations that have, or even small ones, that have a heavy dose of politics, competing units, competing vice presidents, that type of stuff. They're going to engage in satisficing simply because they don't have the resources or they don't have the will to go and expand the bounds of their rationality, the bounds of their understanding of their business and their competitors and their employees, etc. Okay, so that's some important information there in satisficing versus optimizing. And we'll get rid of this. Okay. And then I have a resource here about Vilfredo Pareto and what is known as Pareto efficiency. Now, here's a concept. In terms of the scoring model, we borrow from the reciprocal lattice. And this is a model that we borrowed from the physical sciences. So I want you to see this so I can reinforce to you again that management science, that the problem-solving part really embodies us identifying a model that's out there. And the best model is a mathematical model because it's the one most easily manipulated, the one we can simulate, etc. That's the reason why the three-dimensional virtual reality is rapidly becoming a staple in high-end manufacturing. It's becoming a staple in things like medicine, surgical techniques, because you can see what you can experience the phenomena before you do it for real. Okay. And so we try to find a model, and a reciprocal lattice is one that works here in the scoring, in this issue of scoring. And then I have a link there for you for resources on weighting by pairwise comparison. I want to take a look at those. Okay. Now let me say at the onset that while we're going to look at a model of this scoring case and the model that we'll build doesn't mean that we'll get the right answer. Remember, we all operate on a bounded rationality. That's why we've come to understand that the idea that we can teach a person to manage anything, and there's a great fallacy in that. Okay, and I've learned that in my life that context is really so very important. I've been a university department chairperson. I've been a dean. I ran a campus. I ran a homeowners association where it's kind of a combination of city manager and a park superintendent. I worked for a specialized a non-governmental organization that provided technical services to the state, and I've done consulting out there with large Fortune 100 companies. I can tell you that I'll take those consulting experiences and set them aside and just then talk about the things in which I've worked. And I worked in a planning agency for a non-governmental organization. So every one of those situations were unique. Even within higher education, I've worked in 4 different types of institutions. I've worked in a state-supported institution as a regional university. I worked in a private non-sectarian school. I worked in a proprietary school. And I worked in a private sectarian university. And they're all different, all very different. The cumulative experience helps you, but your knowledge of management, general skills and things will take you to a certain point, but you have to accumulate experience. That's why this idea of bounded rationality is so very important. And these models are elegant and they're beautiful, but again, the statistical artifice is like the proverbial house built on the sand. It won't stand up when the floods come. You have to have that bedrock, that foundation of experience. And for me, one of the most troubling things that I see in capitalism as it's practiced, in the 21st century in this country and in other countries, is this nomadic kind of situation where people work for several firms throughout their career. Companies that fail to promote people from within and to grow people, but really just try to go outside and all the business about mergers and acquisitions so that a firm, rather than growing organically, grows artificially. These are all things that hamper our ability to make good decisions. So we live in an era where we may well be, we may well have managers so specialized and employees so specialized that they may not even be able to do much in the terms of transference of their skills and knowledge within their own industry. And again, it's important to understand this thing we've talked about, the fallacy of equifinality of inputs. Just because we take the same inputs and we process them in the same way, it's not a given that we'll get the same results. And the prime example of that is education. One of the reasons I handle my classes like I do, and I know for many of you it's quite disconcerting, all the emphasizing weeks of independent study and all of this. I understand that. And by the same token, I hope I'm giving you a cue that experience is important. And so I give you a chance to have that experience of working on your own, of having to control your own time. And so those are some of the things embedded in this course. But again, we use that lattice model. It's one that's borrowed from the physical sciences, and you should go take a look at it. Okay? Well, let's look at the scoring key. Well, before we do that, let's go over and take a look there. So we go through these steps. Okay? And again, as the authors tell you, a scoring model, you can see it yourself, enables a decision maker to identify the criteria and indicate the weight or importance of each criterion. You remember when I made the little matrix there, known and unknown, states of nature, known and unknown, alternatives. Okay. Well, we have to engage in some way in terms of again, we engage in some type of probabilistic thinking by weighting criteria, for most important to least important, and or looking at an environment or situations as a series of factors that we can rank. So we're working with that kind of data and that type of mentality. Well, let's move on here. And they've got some weighting for the criteria, and the rating for each criteria and decision alternative. And here we get the model for the first score. That's for each decision alternative. As we come over here, and this is over on page 705, the authors walk us through the criteria. Okay? We have these multiple criteria. And then we come up with a set of weights. Now, here what we've done is we've created what's also known as a Likert scale for all intents and purposes. Very important, somewhat important, average importance, somewhat important, very unimportant. If Dr. Rourke were here and he heard me say what I'm about to say, he'd probably be a little upset with me. I took statistics from an old school statistician who said rankings are not real numbers. They're known as ordinal numbers. And there's no way that someone can tell you that a 5 in terms of importance is really more important than a 1. This is just a statistical shorthand. Okay? And I'm one of those old school people that says these for a great extent are not really numbers. They're not numbers in the sense that we can really do much with them. A rank or an ordinal number assumes something quite important, that we understand the so-called distance or the intensity or some type of qualitative factor that differentiates a 5 from a 4. So this is one of the pieces of the scoring model that you have to be cautious about. And then they show us the weighting scales that they have for the 7 criteria, okay? And they're using a 5. I guess it looks like a weight of 1 to 5. And a 5 is the most important. 4 is somewhat important at infinitum. And you can see already when I talked about Herbert Simon I encourage you to go over there and read about satisficing versus is the satisficing, and then to go read that other source about suboptimality. You can see here that you have two competing interests weighing off against each other. You've got career advancement versus enjoyment of the work. Then you again have another tie between management style and job security. You can see why, when you have these competing interests, that when it becomes competing departments for budget money or competing units within a company, say a company has several subsidiaries, you can understand why this model, we try to use it because it seems to be the best way for us to try to work our way to a decision using multi-criteria decision making. And remember, you'll hear me say this every time we have a class. Chapter 1 and Chapter 2 of our text bring us to the heart of management science, and it's this. There's a difference between solving a problem and making a decision. And you saw that when we went through and studied about mini-max regret, conservative approaches, liberal approaches to estimating what will happen. Those notions of extrapolation and forecasting. Well, let's move on over here for a second. And here we are. And then we create some ratings. And with their weights. And we'll go back to, this is back to 14.1. And remember here, these are subjective weights. Okay. Look at the extent of which it expands your career decision. And we can get a score for a particular alternative based on this weighting method. And then he talks some other sub-criteria. And then the authors walk us here in table 14.3, the computation scores for the 3 decision alternatives. Okay? And you can see them. And we get a score for Chicago, Denver, and Houston. Now, if you look at table 14.3, it's pretty simple. You can see there's not much spread here between these numbers. And if you took the 3 of them, their averages, gosh, you're just not going to see that much difference between them. The median is the 157. That's easy to say. That's the median score. The maximum is 167. We can look at the difference between the median and the highest is 10 points. And then if you go back and the difference between the median, that's the 157, and the lowest score, 149, is 18. So we see a larger gap between the median value and the lowest. It's twice as large as the one between the median and the high score. So if I were to say, well, based on this, I should choose Denver, that's pretty clear if you're comparing it with Houston. On the other hand, if you're comparing Denver with Chicago, there's a difference, but not as pronounced. Okay? So that walks us through the scoring model, and then we'll look at the AHP, okay, on another video. All right, because I'm going to take them one at a time. Now, quickly, let's go back and let's review what we've got going on with this. We start in 704. This is a student who has been offered 3 positions and is going to try to figure out which position he wants to take. Then we walk through a step-by-step process. We develop a list of the criteria to be considered. Okay? This is not too much, this really is not too much different than if we identify the constraints. Then we assign a weight to them, and this weight it's subjective. Then we assign a rating, and then we compute the score for each of the alternatives. And here are the criteria and the weight of the criteria, weight that are applied, and then we see the weights for the 7 job selection criteria. We have the 7 criteria. We have, the weight, the 5, 4, 3, or 2, or 1. We don't have any ones here. And then what that means, or supposedly means, after my soliloquy attacking the use of Likert scales and rankings. Then we have the career advancement issue and the ratings there. And we have their decision alternatives. And the score for each of those criteria. And they show us equation 14.1, which is how we get the sum of those. Then we get some sub-criteria built in: affordability of housing, recreational opportunities, climate. And then here in 14.3 is the computation of the scores for the 3 alternatives. Here's the weight, the rating, and the score for each of those criteria. And then we add them up for each city, and there we go. It's important again to understand this is a subjective process using rankings, which are statistically also known as ordinal data. A statistician, a purist would say, I don't know about that, but we do those all the time. And if we accept the idea that we're operating under bounded rationality, then we simply say we know these are not real numbers. They're rankings, but we don't have any way to really compare them. Now, if you say, well, Dr. Herman, that's not true. There's stuff out in the world I can compare. Yes, one car will have more features, safety features than another. One car will weigh more than the other. One car will have more headroom than the other. Or we can look at, say, food ingredients. The barbecue sauce used by one, Rob's barbecue and Chardonnay is not going to be the same as the one that's used at the rib crib, and there's one's going to be spicier, etc. Let's look at the scoring model, and pretty simple exercise. It's going to have you do that, and we'll look at this key here. I'm going to download it. Okay. And here's the scoring key. And I have the instructions for us here. And we'll pull them over this way. We're going to use the goal seek to obtain a value of 167 for the analyst job in Chicago, but changing the job security rating for Chicago. So you got this analyst job for Chicago, and we're going to change, we're going to use goal seek, okay, to change the job security rating for Chicago. Job security. So we'll go up here. And we're going to use the goal seek. Okay. And we want to obtain a value of 167 for the Chicago. So we're going to set cell, set the unit. We'll find it over here. There it is. To a value of 167. Okay. And we're going to change the cell. Let's just write these down here real quickly. So I'm going to change C26 to 167, and we're going to change by changing job security for Chicago, which is going to be C11. Now we're ready to fly. We're now ready to do the goal seek. And I'm going to set cell C26 to 167 by changing cell C11. So up here, I'll find C11. Now we'll run the goal seek. And we get our response. And we hit our target value. So when we look at the job security, we have a 6.5, and that gets us to a score of 167 for the analysts in Chicago. Let's take just a quick trip around here and look at the math involved, okay? Here's the weight for each of them per criterion. And we get we're basically looking at B6, which is the career advancement rating and the career advancement score for the analyst in Chicago. We have B6, which is the weight for the career advancement, times C6, which is for the analysts in Chicago, and we get the score. Pretty simple. The math here is all simple. It's the setting it up and getting the criteria and etc. Now, if you're a marketing student, one of the uses of this would be, say, with a focus group. When you sit down with a focus group on a product and you provide criteria and then you provide a weight for them. And that's really what's going on with this scoring model. Obviously, if we give something a lower weight, it impacts its scoring calculation. Now, here's a key part of what I'm wanting you to do some thinking about. I can take a high school kid or a junior high or probably kid and have them do this by just simply plugging in the numbers. Here's where I want you to demonstrate a little bit of wisdom. What statistics would you use to compare the 3 new security job ratings? And we have some new ones. And then I want you to provide me a rationale for your answer. Okay, folks, that'll pretty much do it. As I said, I'm just going to cover scoring and then cover AHP. So I think we're good to go there. And I'm going to call it a day. But we've looked at this. As you can see, that it's not all that big of a deal. It's just simply following a process as the text shows us. And I even gave you some hints on how you might handle these. The 3 new ratings under security. So that'll do it, folks. We put our feet in the water a little bit with multi-criteria decision-making models using scoring model. The nice thing about this is a template. You take a decision where you have multiple criteria, develop your weights, calculate the weights, and determine what would be your best choice. It would be up to you to determine what summary statistic, for example, you might use to make the decision. Or you could, and even if you said, well, I'm going to use the range, the high and the low. Well, if the highest is the one you're after, then fine. That'll do it for this, and we'll talk about AHP. We'll look at it in the next screencast. As I said, this will be short because I'm focusing only on this, and I think we've covered it pretty well.